Today's lesson is a simulation of a predator-prey interaction. I have a helper with me today, Riley.
Hi, everybody.
And we are going to be running through this lab. The table in front of you is a representation of a habitat where the snowshoe hares and the lynxes are going to live. And those three green squares in there represent the snowshoe hares. And then the yellow squares will represent the lynx, the predators. So we have the hares are the green and the predators are the yellow, the lynx. And the lynxes will eat the hares. There are certain requirements. The lynx has to eat 3 or more hares to survive and reproduce. So then there will be another hare added to the simulation. Every time that the predator lands on one of the green squares, one of the hares, that means that the lynx has eaten that hare, and that hare will be removed from the simulation. And then we will count the number of hares that are left after each turn. We're going to do this 20 times, and we will double the number of hares because the hares all reproduce as well. So we're going to run through this together. You'll get the hang of it. You're going to record the data on your data table as we go along, and I will show you everything that you need to put on your data table. So in generation 1, we are going to start out with 1 lynx, which is our predator, and 3 hares, which are our prey. And we are going to toss the predator into the habitat and see if he catches any hares to eat.
Okay.
So the lynx got 1. So we're going to take both of those out because he ate that hare. So now that means we're left with 2 hares. So in generation 1, we had 1 hare that was eaten by the lynx. So that means that we have 2 hares remaining in our simulation, and our 1 lynx survived. And because he did not eat 3 or more hares, then he does not produce an offspring, so we don't have anything going into that column there. So for generation 2, that means we're starting out with 1 lynx still, and we double the number of hares that were left, column D, from the previous generation. So 2 doubled is 4 hares, and that's what we're going to start our simulation with for generation 2. So generation 2, again, 1 lynx and 4 hares, and we are going to throw the lynx in there and see if he catches any hares. None. He didn't catch any this time. So that means that he didn't eat anything. He still survives, but he doesn't produce any offspring. And we are going to double the number of hares that are left in there. So now in generation 3, we have 1 lynx that's still surviving. And then we have doubled the number of hares to 8. And we are going to run it one more time. So we're going to throw our predator in. And he has eaten
1
hare. So we're going to take that hare out. We're going to count how many are left, and we're going to double the number of hares. We still are only going to have 1 lynx because he has not eaten 3 or more in order to make an offspring. So at the end of generation 3, we had 7 hares remaining. So that means in this generation 4, we are going to have 14 hares because we've doubled the hares. And we still only have
1 lynx.
Just 1 lynx.
Now I'm gonna throw it in.
Ooh, how many is he actually touching? Oops, careful.
Oh, that was over here.
That's okay.
Yeah. So he finally ate 1, 2, 3 hares.
So that means we're going to subtract those 3 hares, and now that means that the lynx has a baby.
3.
So there's going to be 2 lynxes in the next generation.
Now we have 2 lynx and 22 hares. Now I'm going to throw
One at a time.
one at a time.
Okay. Hang on, we have to take out what he eats now. How many has he touched? He's
3.
touched 3. So take those 3 out. Put those with him. Okay. Now throw the next one.
He has touched 2.
Take those out. So in that last generation, we had 5 hares that were eaten. So that means there were 17 that survived. We had our original 2 lynxes, plus one of them ate 3 hares, so it reproduced. So now in our next generation 6, we have a total of 3 hares and 3 lynxes and 34 hares. So at the end of generation 6, 9 hares were eaten. That means we have 25 remaining. 3 lynxes survived, and 2 of them were able to produce offspring because they ate 3 or more hares. So now we have 5 lynxes in the next generation and 50 hares. So our next generation here, we had 23 eaten, so that means 27 remained, 5 lynxes survived, each one reproduced, so now we have 10 lynxes and 54 hares. So at the end of that generation, there were 35 hares eaten, which left us with 19. 10 lynxes survived, and then 6 of those ate more than 3, so they were able to reproduce. So now we have 14 lynxes, and we have 38 hares. So generation 9, we have some pretty big changes that happened. 34 of the 38 hares were eaten, so there are only 4 hares remaining. 10 of the lynxes survived, 4 of them died, and out of the 10 that survived, 6 of them ate enough hares to be able to produce offspring. So now in generation 10, we are going to have 16 lynxes and only 8 hares. So as you can see at this point, our population of hares has been pretty much returned back to our starting point. We only have 4 hares left, and we only have 5 lynxes left after that last generation. So our populations are both crashing. So we are starting generation 11, and we had 5 lynxes remaining from the last generation, and we only had 2 hares remain. So we double that and we have 4 hares. After tallying all of this up, we ended up with 3 lynxes that died. So we only have 2 remaining for our next generation, and 2 hares were eaten, which left 2 hares remaining. And when we double that, we have 4 hares for generation 12. So 2 hares were eaten, that means 2 are remaining, and the 2 lynxes did survive, and they did not eat enough though to produce offspring. So we still have 2 lynxes and 4 hares for generation 13. So lynx number 1, lynx number 2. We got 2 there. So 3 hares were eaten. That means 1 is remaining, so we double that for the next generation. So we're going to have 2 hares, and we still have 2 lynxes that are hanging on. So now we have 1 lynx and 1 hare. So we had 1 hare remaining and 1 lynx that survived from the last generation. So that means that we are going to only have 1 lynx left, and we had 1 hare survive. So we're going to have 2 hares in this generation. So our 1 lynx survives. So 2 hares because they have duplicated, and 1 lynx. So here's our lynx. Our lynx has not survived or has not eaten any of the hares, so he will survive to the next generation though. So that means we're going to double the hares for this next generation. So in generation 17, we're starting with 1 lynx and 4 hares after replication. So here's our 1 lynx, and he survives but did not eat any of the hares. So we have generation 18 here. We still have our 1 lynx that's hanging on, and we have duplicated the hares remaining from generation 17. So now we have 8 hares in our habitat, and our lynx is only going to consume 1 of them. So we still have 7 hares remaining. Generation 19, we still have our 1 lynx, and the number of hares has duplicated again. So we now have 14 hares. So our lynx consumes 2, not enough to produce offspring. We still have 12 hares remaining. Generation 20, 1 lynx. Now we're up to 24 hares. Our predator only consumes 2 of the 24. So we're left with 22 hares remaining. We still have the 1 lynx. He did not produce enough, did not consume enough to reproduce. So this is what we're left with here. So what do you think would happen next? If we were to continue this, we had 22 hares, so now we would end up with 44 hares. We would still only have 1 lynx. What is going to happen to that population of hares, and what is going to happen to that population of lynxes if we continue this for another 5 or 10 generations? So you're going to think about that, and you're going to answer some of these analysis questions at the bottom here. You are going to make a graph of your data. So you are going to put the generations, right? Time is going to go on the bottom, and your populations are going to go, the population size. So you need to go up to 54 is the largest number we have for the hares. So you need to make sure that you go up to 50 on your graph, and you're going to have 2 lines. 1 line is going to represent the hares, and then another line is going to represent the lynxes, and you are going to graph the data and answer those questions.